Yeah, let's solve this question. This is our today's question that is jump game, and let's try to solve this question. First, read the question. We are given an entire arena. If we are initially at position at the array's first index means index at the zeroth index, and each element in the array represents our maximum jump at that position means there is a number 2, then you can jump up to position of 2 means from this index we can go at max to two index away from this, and if you return true if you can reach the last index or false otherwise. Okay, this is our input array, and if you return the output in true or false, and it's depend upon that whether if we can reach on the at the last index starting from the first index or not. And this is a constant is none of length is 1 to the power 4, and none of I is 1 to the power 5. And let's try to solve this question. Yeah. Let's take an example and try to solve the question. I open my window, and I am trying to I am trying to show you how example uh, how example is given, and how can I how can we build our approach for this question. And let's take an example of sorry, two, three, one, 4. This is our index, that is starting index, where this we are present, and we have to go to our end index, and from this index we can jump up to maximum of num of I. In this question given is that you can represent a maximum jump in that position means we means from means if our index is 2, we we can go to index either this index, and from and if we are here, then we can go either this index this index this index. Okay, let's try to solve the question. Yeah. uh, for this question, let's our since since our index is starting from 0, and our index is starting from 0, and we have to go to here, and we can go to this whether this, and so we can say that there is many options, and you can see that you can see that there is many many indexes where we can go, and if we visit index index t index, let's suppose if you index if you visit the index t, then we are not going not going to visit this index again. Means if we visit this index, then we mark this as true, so that we cannot visit this index in future. So I will try to I will so as, as you can see that we can see that there are There are many options. Means option is basically indexes where we can go in one move. So we have to check for each check for each option, and that's why we have to use DP for solving this question. Let's understand the example. Okay. This is our example. This is our example given. Let's try to make this 2, 3, 1, sorry, 1, 4. This correct. 1, 1, 4. From from index to I can go here. I can go here. If I go if I go to index 3, then from index 3 we can go. You can go one. You can go this. You can go this, and from 3 we can directly go to 4, and our answer is 12. Our answer is will be 12. So, and let's try to solve the let's try to build understand the second example, that is 3, 2, 1, 0, and let's suppose this is 4 or 8. This this index value doesn't matter if we reach at n minus 1 index. Then we have to just return return true. So for this example, we can go from here to here to here. So if we go from 3 to 2, then from 2 we can go 1. Either I you can go 0. If we can go 1, if we can go 1, then from 1 we can go 0. And if we reach 0, from 0 we will not gonna do, we will pointer will not move. If array of I is equal to 0, then pointer cannot move further. So we have to just return 0. So if you go from 2 to 1, 0, and if you go from 2 to 0, then answer will be 0. And if you go from 2 to 1, then it answer is just to 0, and our answer is false. And if you go from 3 to that to 0, then our answer is also false. So for this, our answer is false. So for this, our answer is false. And I think this should be our answer. Yeah, this is our answer. Let's implement our approach. Uh, I'm using DP to solve this, and let's take the size of the given array, and let's make our DP array. That is a that is a type of boolean. Yeah, that is that is the type of int, not boolean, because we have to return. You have to check the value is a field or not, and in boolean there are only two values, so we cannot check if this value is present or not. So let's make it slightly bigger, for avoiding the any overflow, and mark this minus one, and let's make our let's return our function. in which I pass my array and index where I start and our DP array, image my selection so that it can run faster. And uh, let's build the array that is boolean type and the name is all. What my function will do that is check whether we can reach from first index to last index or not. If I will check if I is equals to num dot size minus 1, so we will just return true. And if I is greater than num dot size, then you will just return false. And if our index is if the value of our index is present, it means it's not myself means I already built this array and I already find out the answer for this array. So you have to just return the answer. So we just return this answer. And what we can do that is let's make our answer variable and initialize this is false because we assume that we cannot reach to the last index and just try to check whether I can reach or not. And we will start our index that is I, I, uh, this is also one thing to be if nouns of I is equal to 0, then evaluation of it because we cannot run the code. Okay. I plus 1 to j less than I plus fi both sides from where to conjunct and j plus plus. And if we are answer is equals to or if we will take it or because we want that either because the or function what basically do that is taking or of all the values and if there is any true will present then it returns true. So that way I take or and I will try to solve them and let's mark if a plus a5 is greater than not size means we are going beyond our elastic so we have to just break the loop and nums and where I can I'm going that is j and this is our dp area and let's return or dp of I is equals to answer. Let's try to run my code. Let's see what will happen. Yeah, it's saying I num in order to let's make this a nums and try to solve this. Basically, it's not nouns of I dot sir. It's really nouns of I. Sorry, I made a lot of mistake, but I will try to not do mistake further. Here my code is long. Let's see why. Uh, why my code is long. Let's see. Yeah, we go from j equals to I plus one. J less than I plus j less than r equals to sorry. You can go to I equals to also. Yeah, this is correct. J plus plus. From two you can go this j equals to I plus one. I plus one to j equals I plus num dot psi and I plus num of I minus one. Y minus one. Two if you is starting from two plus zero that is will go to this and from this yeah I plus num of I not minus one. Okay. J plus plus if j plus num of I greater let's do not make this we can our our base condition will handle this case, and let's see why my answer is wrong. Yeah, you have to return here one, not zero, because if I did the last one, then you just have to return the answer that is true. Yeah, my code is good giving sometime error. I don't know what happened to my code. Yeah, if it will be better if I it will be better if I just if if I just break the loop whenever I encounter any size that is sorry, I can make this here minimum of I don't know of I to n. Yeah, yeah, and number. So let's not enough the size minus one, because we don't want to go beyond our number size minus one, because we want to just reach to our last index. Yeah, right. Giving error because of number size is not in function. Let's try to select this. Yeah, this is giving TLD. Let's try to optimize this optimize my code. Let's try to understand why my code is giving TLD. Uh, what is time of thinking my code that is O of n is what? O of not O of n by, yeah, you can see that it's greater than O of n log n, yeah, O of n square. So that means my code is giving TLD for the large test cases. So let's try to let's to optimize my code, and what in your automation, what you can do that is we return true as soon as I get my value is reaches the last index, means with uh, before this what we are doing, that is we going to take all the cases, and uh, if there is true, then we are outing our answers and return in the last after all the after all operation performed. But what for optimization, what we are going to do, that is we are going to return as soon as we reach the last index. So let's try to implement my logic that will not cause clearly. Okay. And if that is our j, that where I can reach if it is lesser than our area size, and our function that is we when you call the function, if it is return true, if this will return true, that means from this index I can reach to last index, and so means you have to return true. Else you have to return false. And let's try to move my code so that my code will not clearly for the last test case, and it will restore the answer for all the test cases. Let's try to run this my code. Uh, yeah, this is giving AC. Yeah, it will return like this. Yeah, this is giving accepted. Let's try to submit it. Yeah, my solution is accepted for this. Let's try to we, use some more optimized approach. I found a greedy int where you will check reach equals to 0 and for int I equals to 0 I less than and I plus plus, and if where I can reach is is less than I means you cannot reach you cannot reach this I of in this means you just return false, and what you have to do is it you have to increase our this function so that we can let's see either we can reach our index or not, and that will be reach maximum of reach are I plus num of I, and if reach is greater than num dot size, then we have to return true. So let's return which is greater than or equals to num dot size minus 1. By minus 1, that is if we reach the last loop, that will be a total. Yeah, we are not declared our case size of array. Let's try to run this code, and this is accepted, and this is our accepted solution. You can also try to approach my DP approach, my bottom of video, my bottom of DP approach. Yeah, bottom of DP is basically we have to think in reverse manner as we have to think in reverse manner as we think in as we think in recursion. So let's try to implement in and go to dot size and vector. Let's take bool linear of dp where n plus 1 and all mark all the value false because we cannot reach all the value. Let's and dp of 0, let's mark it true because we are at this index, and let's try to run for int I equals to 0 y less than I plus plus, and for int j equals to I say I to j uh, from j equals to I plus 1 to j less than I plus a of I j plus plus. If j plus a of I is greater than if j plus a of I is greater than n, we have to first we check if dp of n n minus 1 is equals to true. We have to just return true our answer. If j plus I greater than r equals to 1, we have to just bring this value, and for all of that we have to just take dp of j is equals to 2. Let's return false. That is one month of I. Yeah, here also month of I. Let's try to think where our code is wrong. dp of 0 is true, and we are running from I to 0 to 0 to I less than I plus plus dp of equal to I plus 1, so dp is I plus 1 of I j plus plus. And from 2 we can go 3 and 1, and we mark dp of j equals to true, and from 3 if dp of j what is yeah, we implemented this our bottom up approach. This is bottom up dp, and let's Let's try to run this. Here DP of I we are checking. We are checking because if we cannot reach this index, so we run cannot jump from this index. So let's try to submit this code. Yeah, our code is accepted, and let's try to enlarge our time capacity and space capacity. The time capacity will be O of n O of n square, and space complexity is O of n. That will be dp result for this. And we also submitted our O of n approach and O of n time complexity and O of one space complexity approach. And this is our approach to solve this question, and that's all for this question. Let's see you again in another lecture. Bye.